Hello macroeconomics students. Today we're going to be looking at Chapter 3, Interdependence and the Gains from Trade. In order to understand trade, we need to start with the Production Possibilities Frontier Model. This is a model that looks at the production possibilities for nations and how it allows us to understand the basis of trade, which is opportunity cost, the cost of producing one good in terms of what is given up in production of the other good. So we'll start with the model itself. It's a graphical model that demonstrates the concepts that we're going to be looking at. We look at 4 key assumptions in this model. First, we make the assumption that only 2 goods can be produced. This is a simplifying assumption so that as we're looking at the cost of one good, we can see what is given up of the other good. So 2 goods are being looked at. The resources are being fully employed in this situation, and resources and technology are both fixed. This is that ceteris paribus assumption that we use with all economic models. That is that we hold all outside factors constant while analyzing the things that we're looking at specifically in the model. Here's an example of a production possibilities model and the table and the values used for it. So here you've got bikes and computers. If this nation uses all of its resources to produce bikes, it can produce 14 bikes, but it cannot produce any computers. And if they use all of their resources here, they could produce 8 computers, but no bikes. B, C, and D are points in which they can have a combination of production. All of this assumes that they're using all of their resources fully. So each point then represents a specific combination of goods that can be produced. When we put this into graphical context, we can see that we plot those points, and it creates a frontier or a limit. And this line represents the production possibilities curve or frontier because the points on the line can be produced. In fact, any point on the line is what we'd call efficient because we're fully utilizing all of our resources. Any point inside the line can also be produced, however, because it's not fully utilizing all of the resources, then it would be inefficient. So you have some unemployed resources. So for example, if we produced a combination of 6 bikes and 2 computers, we have the resources to do it. However, it's not efficient. A point outside the curve would be impossible given the current resources that are available. You could reach that point through economic growth, but in this scenario, it's not attainable. The biggest thing you should be able to see from this model is the trade-off between bikes and computers, the production trade-off. So if, as a nation, we decide that we're going to produce 14 bikes, we can produce 0 computers. However, if we decide that we want to produce 2 computers, we must give up some bike production. So if we produce 2 computers, then we're only able to produce 12 bikes. So point B tells us that there's an opportunity cost to producing 2 computers. Specifically, if we're using this model, the opportunity cost of producing these 2 computers is the 2 bikes that could have been produced with the same resources. So opportunity cost is the key element that we'll be looking at in this model as we connect it to trade and production possibilities. There are 2 types of production possibilities trade-offs. One is called constant opportunity cost, and that happens when you have resources that are highly adaptable. So calzones and pizzas are a good example. For each calzone that I make, I give up the opportunity to make a pizza. And it's going to be constant because the resources are adaptable. I can use the same resources to make calzone or pizza. So this, if I graphed it, is going to give me a straight line, a production possibilities curve that is a straight line, meaning that it has a constant slope. And this would not normally be something you see. However, when we're looking at international trade and comparative advantage, this is the one that we're going to use because it's a simpler model to evaluate. The other form is increasing opportunity costs. And you have that when you have 2 very different products using very different inputs. So in this case, pizza and robots. Pizza obviously takes very different resources to produce than robots. So if I want to produce 1 robot, I give up 1 pizza. The cost is relatively low. However, if I want to produce a second robot, I'm going to have to shift my resources, my land, my labor, my capital. They're going to have to shift into robot production. And that means that they're going to take more away from pizza production because they're very, very different resources and they can't go back and forth easily. So once I have shifted my production to robot producing, then I'm going to give up more pizzas. If I produce a third robot, I'm going to give up 4 pizzas, and it's going to continue on until I'm using all of my resources to produce robots very different from pizzas. So we call this increasing opportunity cost, and it's because you have very different resources that go into it. And the result here is going to be a bowed out curve, also called concave. Concave meaning the concave portion is facing the origin. So here's a good example, a little chance to practice this and make sure you understand that concept. Corn and wheat versus cactus and pineapples. Which one would have a constant or straight line opportunity cost? Which one would have increasing? And what you can see is corn and wheat are going to be made with very, very similar inputs. The land, the labor, the capital are going to be almost identical. Therefore, it's going to have a straight line production possibilities curve. Cactus and pineapple, on the other hand, have very, very different inputs. Therefore, as I produce more pineapple, I'm going to be giving up more and more cactus production as I'm shifting my resources to be more suited to pineapple production. Here you can see that with the corn and wheat, you have constant opportunity costs. So if we looked at the slope of this line, it would be constant. And that's going to be an important thing coming up when we look at comparative advantage. With the curved out line, you have increasing opportunity costs, and with the curved line, the slope of it is different at every point on that line. So for simplicity's sake, we'll be using the straight line production possibilities curve when we're looking at comparative advantage. When discussing comparative advantage and absolute advantage, we need to start with an understanding of what absolute advantage is. Absolute advantage is simply the ability of one nation to produce more than the other given the same inputs. When we talk about comparative advantage, that's going to be comparing the opportunity costs, and that is the basis for trade. To understand opportunity cost in the context of comparative advantage, it's important that we know how to calculate per unit opportunity cost, because as we're comparing the cost of production, we have to standardize it to a single unit so we can compare apples to apples when we're making these evaluations. So let's do a little practice with the concept of per unit opportunity cost. A formula here at the top shows you that you can take the opportunity cost, meaning what is given up in terms of production, divided by the units gained when a decision is made to produce. So here we'll give some example and we can work through a few. Assume that it costs you $50 to produce 5 t-shirts. Most people won't have any problem with that, and we say the per unit cost for each shirt is obviously $10 per shirt. So all we're going to do when we're looking at comparative advantage is we're going to do the same thing, but now we're going to look at it instead of in terms of cost, we're going to look at it in terms of what you gave up, what you would have made, which is also cost, but it's a little bit different to see it. So now instead of producing 5 shirts, let's say you could have made 10 hats. And so you should be able to calculate your per unit opportunity cost for each shirt in terms of how many hats that you gave up. You made the choice to produce shirts instead of hats, so what did you give up in terms of hat production? So here you can see that for each shirt you produced, you gave up 2 hats. And if you plug it into the formula here, you can see the opportunity cost was 10 hats, units gained was 5 shirts, and so standardizing it to per unit, we can say for each individual shirt, we gave up 2 hats. Another opportunity to practice is to look at that in reverse. Your per unit opportunity cost for each hat in terms of shirts given up, and we do the same calculation. We can say the opportunity cost, I could have made 5 shirts, and the units gained were, I gained 10 hats. So again, I'm going to just do that simple calculation, and it tells me that each hat costs 1/2 of a shirt. Another way to do this is you can simply take the reciprocal when you're looking at two items, and you calculate the cost of one, the other one is going to be the reciprocal. Here's another opportunity to practice with per unit opportunity cost. Given the information you have here, you can take a moment and calculate the opportunity cost for each of these producers to produce one pizza and one burger. And this gives you a chance to practice either using that formula or using, if you prefer, a more common sense approach. But either way, you should be able to calculate. And pause the video if you'd like. Give it a moment. And then I'll run through it. So with Ronald's opportunity cost for one pizza, well, he could produce 20 pizzas or 200 burgers. If we put into the formula, the opportunity cost, what he gave up, was he made one pizza in terms of burgers, so 200, and he produced 20 pizzas. So if we standardize that to the per unit, we can see that each pizza cost 10 burgers, right? So 200 divided by 20. Then we can take the reciprocal of that, or we can run through the calculation again, whichever you prefer. But his opportunity cost for one burger in terms of pizzas given up is going to be, for each pizza, he gives up 1/10 of a burger. Right. Again, Papa John, same concept, different numbers. And so we're going to say he could produce 100 pizzas, 200 burgers. And so the burgers were given up. So his opportunity cost was 200 burgers, and his gain was 100 pizzas. So turn that into per unit, divide by 200 by 100, and you'll see that one pizza costs 2 burgers. And the reciprocal is true here, or we can say 100 pizzas divided by 200 burgers is going to give us one burger costing 1/2 of a pizza. So this helps us see that we standardize it. So now we can do comparisons, because before we had the total production possibilities for Ronald and Papa John, but we didn't have a clear understanding of who could do what more efficiently. Now with this information, we can do some calculations and see who can produce cheaper pizzas, and by cheaper I mean at a lower opportunity cost, and who can produce burgers at a lower opportunity cost. And without going any further, we can take a quick look. For Ronald McDonald, one pizza cost 10 burgers. For Papa John, one pizza cost 2 burgers. So we can see right away from this that Papa John can produce pizzas cheaper. Therefore, he has what we call a comparative advantage. For Ronald, one burger, so let's switch to the burger side, costs 1/10 of a pizza, whereas for Papa John to produce a burger, it costs half a pizza. So the producer that can produce burgers cheaper is Ronald McDonald. So we would say that he has the comparative advantage in burger production because he can do it cheaper. And this is a really important concept. By cheaper, I mean what he gives up in terms of the other good. And so he has the comparative advantage in burger production. Papa John has the comparative advantage in pizza production. So we can see that just from this information. So absolute advantage, go back to that, and here's our definition of absolute advantage. The producer that can produce the most or requires the least amount of inputs, one definition or the other. And in the previous example, Papa John has an absolute advantage in pizza production because he can produce 100 and Ronald can make 20. And the assumption there is that they're using the same amount of resources or inputs. Comparative advantage is what we just saw with the comparison of opportunity costs. And so comparative advantage goes to the producer with the lowest opportunity cost. And so what we just saw was that Ronald has a comparative advantage in burgers and Papa John has the comparative advantage in pizzas. In both cases, they had the lowest per unit opportunity cost. Hopefully you can see the benefit of breaking it down to the per unit costs so that you can do a very clear comparison. So what we know from comparative advantage is that if a country has a comparative advantage in producing something, they should trade. They should specialize in that good and trade. So if one nation has a comparative advantage in producing a good, it is in their best interest to produce that good, to specialize in it, and then to export it to other countries. And we'll talk about the terms of trade and how they can benefit from that. But it is going to be in their best advantage, especially if another country has something that they need and they can exchange the thing that they cannot produce at the lower opportunity cost. So let's look at some examples of this. This is a great example. You've got two countries here. You've got USA and Brazil. They both produce wheat and sugar. From the production possibilities frontiers below, we can see what their maximum production is given the fact that they're using all of their resources. So the United States, using all of their resources, can produce 30 tons of sugar and 30 tons of wheat. Brazil, on the other hand, can produce only 20 tons of sugar and 10 tons of wheat, and that's using all of their resources. What you see there is that America has an absolute advantage in producing sugar and wheat, which might beg the question, why would you trade with another nation? But you're going to see that the basis of trade is comparative advantage. So let's put the numbers from the production possibilities curves into the chart here to help us measure opportunity costs. And we're going to go back to that per unit opportunity cost. So now we can see a little bit of a comparison, but even now we need to know per unit because the raw numbers like this aren't going to be very helpful to us. So we can do some comparison. We can see a very easy one for the USA. If they can produce 30 wheat or 30 sugar, then each wheat costs them 1 sugar, and each sugar costs them 1 wheat. Brazil, on the other hand, can produce either 10 wheat or 20 sugar. So for each wheat they produce, they give up the production of 2 sugar, and for each sugar they produce, they give up 1/2 of a wheat. Notice that there's the reciprocal there, right? 2 and 1/2. It's kind of a nice, easy little shortcut to getting to that information. Now that you've got this, you can compare the opportunity cost very easily. We can see that in wheat production, the USA's cost is 1 sugar, Brazil's cost is 2 sugar. So clearly the USA can produce wheat cheaper. And in sugar production, USA, 1 sugar costs 1 wheat, and for Brazil, it only costs 1/2 of a wheat. Therefore, we can see that Brazil has a lower opportunity cost or comparative advantage in sugar. So once we identify that, we can say that the USA should specialize and export wheat, and Brazil should specialize in and export sugar. And the two nations should trade. The USA should import sugar from Brazil, and Brazil should import wheat from the US. So we can see who has comparative advantage, we can see absolute advantage, and we can see who should import and export. And if this gives you trouble, pause the video, go back through it, ask yourself these 3 questions, make sure that this part is clear to you. Following from that information, we can say that the USA should specialize and produce only wheat, which means that 30 tons of wheat are going to be produced. And Brazil is going to specialize and produce only sugar, which means that 20 tons of sugar are going to be produced. And we can see now what that's going to mean in terms of trade. The nations are going to have 30 tons of wheat and 20 tons of sugar to work with. So let's say that they set the terms of trade at 1 wheat for 1.5 sugars. So the United States is going to specialize and export wheat, and Brazil is going to export sugar, and they come to this agreement that they're going to trade 1 wheat for 1.5 sugars. Well, let me just show you what that's going to look like. So this is sugar and wheat production and consumption for the United States. So we just kind of can go down the chart here and say, well, they're producing 0 sugar and 30 wheat, right? We already know that for the United States. If they import 1.5 sugar, they give up 1 wheat, because those are the terms of trade. So we can just kind of follow the numbers here. So if they have 3 sugars, they've imported them, they've traded away 2 of the wheat that they've produced, and so on and so forth. So we follow that down here. When we get to this point, they've got 15 sugars, they've imported them, 20 wheat that they've kept. I want you to see something interesting. If you go to the chart and look at 15 sugar and 20 wheat and come together, that point is right about here. And notice that it is outside of their production possibilities frontier. This is the benefits of trade, because without trade, the maximum combination they could have produced would have been about here at 15 and 15. But with trade, the benefits of trade, even though Brazil is a less productive country in many ways, the benefits of trade are that they can now consume outside of their curve at this 15 and 20 point. On the other side, we can do the same thing with Brazil. Look at Brazil. They're going to produce 20 sugar and 0 wheat, because they are specializing. So if they trade away 1.5 sugar, they get 1 wheat in exchange. And this is the numbers, right? We can go to 17 and 2. And we can follow those numbers down. We get down here where they have traded away 15 of their sugars. They're left with 5 sugars, and they've imported 10 wheat. And this is going to be their consumption here, because this was what they're left with. So go to that point on the graph, and you'll see that 5 and 10 is a point just right here, just outside of their production possibilities frontier. Normally, that point would be unattainable given current resources, but trade makes it possible for them to consume at a point beyond their production possibilities frontier. So that's a really important thing to understand, because the gains from trade are consumption gains. When two nations specialize in trade what they can produce at the lowest opportunity cost, both nations are better off. Even though on the surface with absolute advantage, it doesn't seem like it should be that way, this is one of the amazing things about trade and how it expands economic well-being. And here's another look at that same idea, that after trade, essentially, if we treat this blue curve as, let's say, a consumption curve rather than production, they're actually able to consume more after trade. The next concept is going to be the terms of trade. So I told you that the terms of trade for this exercise were 1 wheat for 1.5 sugar. That was what Brazil and the United States agreed to, right? 1.5 sugar for 1 wheat. Let me show you where that came from, and then we'll do a little more elaboration on the terms of trade. The terms of trade fall between the opportunity costs. So for 1 wheat, the 1 wheat should cost for the country importing it somewhere between 1 and 2 sugars. So that's where that came from, and I'm going to elaborate that, but I just wanted you to see why that number was chosen, because the opportunity cost for 1 wheat comes somewhere between. It could have been 1.25 sugars. I happen to choose 1.5, but I want you to see that that number was significant and it meant something, and it didn't come from nowhere. So let's talk about terms of trade. These are the agreed upon conditions that are going to make both countries better off when these trades are made. So let's talk pineapples and radios with Kenya and India. So right now we can start and go back to the beginning of our understanding of per unit opportunity costs. We can very quickly see what 1 pineapple will cost in terms of radios. It's going to be, 1 pineapple is going to be 1/3 of a radio. We'll go through all these steps. And 1 radio is going to cost Kenya 3 pineapples to produce. And by the way, I'm using a little shortcut memory trick I learned, and that is when outputs vary, and in this case outputs are pineapples and radios. So when the outputs vary, I just use a little memory trick that's other goes over. So 10 over 30 gives me 1/3. 30 over 10 gives me 3. And that's a nice little memory trick if you ever get stuck on this. So here we go. So for Kenya, 1 pineapple costs 1/3 of a radio. For Kenya, 1 radio costs 3 pineapple. For India, another nice easy one. 1 pineapple costs 1 radio. 1 radio costs 1 pineapple. So right now we can compare the opportunity costs. We can see that Kenya can produce pineapples much cheaper, and India can produce radios cheaper. And so we can identify those opportunity costs. We understand that those countries should specialize in what they do at the lower opportunity cost and trade. But now let's talk terms of trade. So Kenya wants radios, right? Because they're specializing in pineapple. They're going to export pineapple and import radios. So they want to buy radios, but they don't want to pay more for the radio than it would cost them to produce it themselves. So right away you should be able to look at this and say, well, if Kenya produces 1 radio, it costs them 3 pineapples. So they want to be able to buy a radio for less than 3 pineapples. And India is not going to sell a radio for less than 1 pineapple because it costs them 1 pineapple to make it. So they're not going to sell it for less than it costs them to make it, or they'd lose on the deal. So right away we can see that the terms of trade for one radio is going to be between 1 and 3. If it's greater than 3, Kenya says, hey, it only cost me 3 pineapples to make a radio. I'll get radios somewhere else, or I'll make them myself. But if it's somewhere between 1 and 3, then they're better off. If they can get a radio for 2 pineapples, it's cheaper than they could have produced it themselves. So India, on the other side of that, of course, wants to sell it for at least what it costs them to produce it. So the terms of trade here, in order for both countries to be better off, are between 1 pineapple and 3 pineapple for a radio. India is in a different situation. They want pineapples. They're producing radios, exporting radios, and now they're going to import pineapples. Again, if they're going to produce their own pineapple, it costs them 1 radio. So they don't want to pay more than a radio, or they're just going to produce pineapple themselves. Kenya isn't going to sell a pineapple for less than 1/3 of a radio because that's what it costs them to produce it. So the terms of trade for both countries to be better off are going to be between 1/3 and 1 radio for each pineapple exchanged. So this is how both countries make themselves better off, is by finding the terms of trade that fall between those opportunity costs. And I know that in your homework this week, you're asked to find that spot between the 2 opportunity costs. All right, so I wish you lots of luck as you're moving forward this week. In the homework, you're going to be asked to recognize the terms of trade. You'll be asked to recognize the constant and increasing opportunity costs, production possibilities, frontiers. They will ask you to calculate the benefits of trade. But once you can calculate the opportunity costs, then the rest of it will build on each concept, and you should be in good shape. Your book has some excellent examples. Make sure you read chapter 3. And we'll talk on Thursday night in our weekly office hours meeting if you'd like to join me and bring any questions. But I wish you the best of luck.